All right, so we're going to be solving 3 problems involving a sliding ladder. The first one, it looks at the rate of change in the height. The second one, the rate of change in an angle. And the third one is the rate of change in the area of the triangle. Right. Whenever we're solving a related rate problem, we should figure out what we know, what we want to know, and how they're related. Right, so here what we know we have a 26-foot ladder. Leaning against a house, we know that the base, the horizontal distance, is 10 feet. And we know the rate of change in that horizontal distance, the dx dt, is 4 feet. Okay. That would be positive. It would be increasing because as the ladder slides, the base is getting farther and farther away from the wall. Okay. So actually I'm going to label these things. So this would be x, this would be y, this would be the ladder here, which is 26. X is 10. Dx dt, it's moving that way, is 4 feet per second. Oh, excuse me, 4 feet per second. What we want to know is the rate of change in the height of the ladder. We want to know dy dt. How they're related? Well, the vertical distance, the wall, or the house I should say, the house, the ladder, and the ground make a right triangle. Make a right triangle, and so they're related using Pythagorean theorem. Right, so all the things we know are up there. We do not know the height that the ladder is as it's sliding. We also do not know dy dt. That's what we're actually solving for. We can find y pretty easily, though, using Pythagorean theorem. This is just geometry or algebra. This isn't. This part here isn't calculus at all. So x squared plus y squared equals s squared. X is 10. And s is 26. 100 plus y squared equals 676. Subtract 100 from both sides, and y squared is 576. That is a perfect square. It won't always be a perfect square, but this one is. It's square root of 576 is 24. So now we know what y is. Y is 24. So cross that off. It's 24 feet. And dy dt is what we're looking for. So now we're going to use the formula that relates them together, Pythagorean theorem, and use implicit differentiation with that. Okay? So what relates them together? X squared plus y squared equals s squared. Okay? And so now we'll use implicit differentiation. And that's with respect to time. Okay, these will always be with respect to time because things are happening over time. Things are moving over time. All right, so first thing you do is you are going to differentiate first. Okay? Do no substitution. All right, so let's look at one of our quantities here, and that's the ladder. The ladder is not changing. Okay? It can slide, it can fall on the ground, but it's going to be 26 feet. Okay? Unless you go take a hacksaw and cut it into pieces, no, that sliding is not going to change the length of the ladder. So s here is a constant. So ladder s is constant, and we know that the derivative of a constant is 0. Okay? So the derivative, there should be an a there. Derivative is 0. Okay. So that's just a big old 0. Okay. All right, so now let's take the derivative of x squared. We're taking it with respect to time. So the derivative of x squared is 2x. With respect to time means we need dx dt, because we're taking it with respect to another variable. Derivative of y squared, okay, exponent moves in front. Reduce the exponent by 1, so we have 2y, but we're taking it with respect to time. So we need to include dy dt equals 0. Okay. So now we've done that part. We want to solve for dy dt. So we're isolating dy dt. So we have 2y dy dt equals negative 2x dx dt. That thing is a d. Doesn't really look like it. No, still doesn't look like it. dt. All right, so now let's isolate the dy dt. We can divide both sides by 2, and we have y dy dt equals negative x dx dt, and then again just divide both sides by y, and we have dy dt equals negative x dx dt, all divided by y. Now substitute. So now you're going to substitute all known quantities. And actually everything is known except for what you're solving for, dy dt. All right, so I'll change colors here so you can see it. Dy dt equals negative x. X is 10. Dx dt is 4. So negative 10 times 4 divided by y, which is over here, 24. I'm going to move over a little bit. So dy dt equals negative 40 over 24, which reduces, both of those are divisible by 8, so we have negative 5/3. Don't forget your units, feet per second. So there's our answer right here. Okay, that's all there is to it. All right, let's solve the next problem. Okay, so again, these things are going to make a triangle. And again, we know the same thing, except what we want is different. Okay, so we know that the ladder is 26 feet. We know x, the horizontal distance, is 10 feet. We know that it's moving away from the wall, so in a positive direction, 4 feet per second. And you still know everything you saw, anything you solved for in the last problem, you now know. Okay, those don't change. Those, once we, if we use Pythagorean theorem, we solve for y, we get the same answer. Okay, so we also know that y is 24 feet. Okay, we don't know that from this problem, but we know it from the last problem, and it's still the same scenario here. We solve for dy dt, and that's negative 5/3 feet per second. Because we'll probably need these things. Okay. What we want to know the rate of change for angle theta is right there. Angle theta makes with the ground. Okay, so it would have to be that one anyway because that's not changing. That's a right angle. So we want d theta dt. How are they related? Okay. They still make a right triangle. So the house, ground, and ladder make a right triangle. So what we can use to solve are trig ratios, because this is a right triangle, and we're dealing with an angle. Okay? So they're related using trig ratio, because it's a right triangle. Which one? Well, there's only one good choice. Let me put everything up here. So y is 24, dy dt is negative 5/3 feet per second. X is 10, and dx dt is 4 feet per second. The only bad side to use here in our trig ratio is the one that's not moving, the one that's not changing. Okay, so don't use the hypotenuse when you choose your trig ratio, because the ladder's not changing. Okay, that'll be a problem. So don't use the hypotenuse. It's not changing. Sometimes we'll use the hypotenuse at a problem involving a right triangle, just not this one, because we have one value that stays the same all the time. All right, so which trig ratio? I should say ratios. Do not use the hypotenuse. That would be tangent and cotangent. Let's use tangent. Okay, I think that would be easier. So tangent theta is opposite over adjacent. In this case, the opposite is y, and the adjacent is x. Right? So that one's opposite. This one here is adjacent. Right? So that means that tangent theta is y over x. And now we have the equation to use. I'm going to do just one more thing before we take the derivative. We use implicit differentiation. The one more little thing I'm going to do is, so we have tangent theta equals y over x. I'm just going to change this from being a quotient to a product by multiplying both sides by x. So x tangent theta equals y, and now we'll just use the product rule. Okay? So we have implicit differentiation. Yeah. And we're going to use product rule. Okay, and remember, product rule is the first times the derivative of the second plus second times derivative of the first. So u is x. Derivative of that is going to be 1. And v is tangent theta. Derivative of that is secant squared theta. Just one other thing, don't forget though, this is implicit differentiation, and it is with respect to time. So we are going to have dx dt, d theta dt, dy dt as we take the derivative here. All right, so first is x times the derivative of tangent theta will be secant squared theta d theta dt equals, plus, I started to write the plus and then I didn't put the other line in, plus the second times the derivative of the first. I hope I have room here, gosh. Can everybody move over a little bit? So we have, fortunately, the derivative of x is just 1. So we're going to have then the derivative, we're going to have just 1 times tangent theta. And don't forget, though, it would be the derivative of x is going to be 1, but it's going to be dx dt. So it'd be 1 dx dt. And then tangent theta. And I have absolutely no room here. I have to shrink it here. You know what? Let's shrink everybody. There we go. I'll just get rid of that. Move this. And that. And oops. If we can just get that x to move. There we go. Now I have some space. All right, let's make sure we got this written down right. X secant squared theta d theta dt plus derivative of x would be dx dt tangent theta, because that's just the second there, equals, and the derivative of y is going to be dy dt. Let's make that smaller too. There we go. All right, so now we want to solve for d theta dt. All right, so we're just going to move everybody on the other side except for the d theta dt. So we've got x secant squared theta d theta dt equals dy dt minus dx. Oh my gosh, what a horrible x. Dx dt tangent theta. There we go. All right, and so now we're just going to divide both sides by x secant squared theta. Okay, so we have d theta dt equals dy dt minus dx dt tangent theta all over x secant squared theta. Now that looks just awful, doesn't it? However, all we have to do now is substitute the values in and simplify. So now it's just a plug and chug. All right, so dy dt, okay, so I'm going to just write down. So substitute and simplify. So this is the easy part. The derivative wasn't too tough, a little tougher than the last one. And the substituting and simplifying isn't too tough. So dy dt is negative 5/3. Dx dt, but my y's and my x's kind of look alike, don't they? That's an x. Is 4. And tangent theta, right? So tangent theta is right up there, right? Y over x. And x, oops, probably should write that down, huh? That it's tangent theta. So tangent theta is y over x. And we know, actually, let's plug in the values. So that's just y was 24, right? And x is 10. And let's just reduce that. So that would reduce to 12/5. Okay, so that's all tangent theta is. It's just 12/5. And then secant squared theta. Okay, well, secant is just the reverse of, or inverse, the reciprocal, not the inverse, reciprocal of cosine. So here, if we look at our triangle here, cosine would be the adjacent 10 over the hypotenuse 26. So secant is just going to be 26 over 10. Right? So, you know, oops, come on. So the trig ratios for a given angle, they're just the ratio of the sides. That's it. No big deal. No big deal at all. So secant squared theta is going to be s over x squared, right, because the whole thing's squared. And s was 26. And x was 10. And let's reduce that before we square. So that would be 13 over 5 squared, which is 169 over 25. Right? So those are all our values, right? So we've got, I wanted to box it to make it easier to see them, but maybe it's not easier. Negative 5/3, the 4, the 12/5. Well, it's not going to be easier if I write over the numbers here. And then the 169/25. That's everybody, right? Did I miss anybody? I don't think so. Nope, I don't see anybody missing. All right, so let's just substitute and simplify over here. So we have d theta dt equals dy dt, which was negative 5/3, minus dx dt is 4 times tangent theta is 12 over 5. Be nice if these numbers were a little nicer, huh? X is, oh, I didn't write that down, but x is 10. Here, squeeze him in here. X equals 10. So 10 times 169 over 25. Right? And so now let's just simplify that. So d theta dt is negative 5/3 minus, that would be 48/5 all over. That'll reduce a little bit. 5 and 2. So that's all over 338. Right, that'd be 300 and then 19. Yeah, 338 fifths. All right, so let's just change these so we can actually subtract them. So I'm going to change this to have a denominator of 15, which means we need to change the numerator to 25. And so now this will be 15. And 3 times 48 is going to be 120 plus 20, 144, right? Uh-huh. All right, so now we've got, almost done. The multiplying and dividing is going to take us longer. D theta dt is 25 minus 144, so that's going to be, it's late, negative 119. Yes. 15ths divided by 338 fifths. Dividing by a fraction is the same as multiplying by the reciprocal. Times 5 over 338, and that reduces pretty nicely. This would be a 1, this would be a 3, that would be a 1, right? This would be a 2, right? No, wait. No. Well, that would have been nice, wouldn't it? The 5 and 15 were right. They look so close together. There were 238. Sorry. But this would still be a 1, and this would be a 3. And so now we'll just multiply across, and we've got negative 119 over 3 times 338. Well, I'm tired, so I'm going to just use a calculator. 1,014. So that's the change in our angle there. D theta dt is changing at a rate of negative 119 over 1,014. Don't forget your units of measure. radians per second. Whew. Not a pretty number, but it's okay. All right, 5 minutes. I don't like these to be more than 30 minutes. Let's see if I can do the next problem in 5 minutes. This one just took a lot with the simplifying, but really the differentiating wasn't that complicated. I just made up the numbers when I made up the problem, and so, well, the numbers were a little unfriendly. Same situation here, 26-foot ladder, blah, blah, blah. And we want to know the rate of change in the area of the triangle. Okay, so we know all the same things we knew before. We know that S is 26 feet. We know that X is 10 feet. We know that Y is 24 feet. Oh, by the way, on that last problem, notice that it's negative. Oh, can't see it anymore. Notice that it's negative, so that angle is decreasing. I forgot to mention that. We don't need the d theta dt, we just need dx dt, which is 4, and dy dt, which is negative 5 thirds. Oh, feet per second. Yeah, I'm not going to be able to move those. Include the units. And dy dt is negative 5 thirds feet per second. That's what we know. What do we want? The rate of change in the area of the triangle. We want dA dt. How are they related? Well, the sides are related to the area using the formula for area of a triangle. And the formula for the area of the triangle, A equals 1/2 base times height. Okay? So again, we will use the product rule in this one. I'm not going to label I have the dx dt and dy dt over there. I'm not going to label it on the triangle, but I will label that this is 24, and this is 10, and this is 26. Okay? This would be the base, and this would be the height. Do not do any substituting, however, until you take the derivative. So again, implicit differentiation with respect to time. That's our next step. All right, so we're using that formula there. A equals 1/2 base times height. Okay. The 1/2 is just a constant there, right? So we have, and excuse me, it's a coefficient there in front of our base. And that's all it is. So again, we're going to use product rule. Okay. So I'll keep the 1/2 with the b. So u is 1/2 b, and v is h. Right? So we're taking with respect to time. So du is going to be 1/2 dB dt. And derivative of h would have just been 1, except it's with respect to time. So dv is dh dt. If I don't write that, I have nothing else to write, so other than a 1. All right, so here everything is changing. So we take the derivative of a, that would be dA dt. There's nothing staying the same in this one except for the ladder. But we don't use the ladder. We don't use the hypotenuse to find the area of a triangle. So dA dt equals u 1/2 b. I gotta move this over. Come on, move everybody over. Everybody go. I never leave myself enough room. All right, 1/2 b times dh dt plus the second, oops, yeah, plus the first, the second times the derivative of the first. So h times 1/2 dB dt. There we go. All right, so we don't have to solve for a variable here because what we're looking for is dA dt. It's already isolated. So now all we have to do is substitute and simplify. Okay, so now we're up to the easy part. So dA dt equals 1/2 times the base, which was 10. Oh, maybe I'll put that here. So, and actually I probably should have, instead of putting base and height, I could have put x and y. Okay, if you like that better. So b is 10, because it's the same as x. H, the dB dt is 4. It's the same as dx dt. And h is 24, and dh dt is -5/3. Okay. So we have 1/2 times 10 times -5/3 plus 24 times 1/2. Oh, gosh. Everybody move again. Times, what am I missing? dB dt times 4. So dA dt equals 1/2 times 10 is going to be 5 times -5/3 is going to be -25/3 plus half. 24 times half is going to be 12 times 4 is 48, or 24 times 2. Any way you look at it, it's still going to be 48. And we need a common denominator so we can add these things together. So pluck a 3 over here, which means we've got to multiply that by 3, which was 144. So dA dt is -25/3 times 144, plus 144/3 is going to give us 119/3 feet squared per second, because area is measured in square units. And so this time the area is increasing. I guess that's because our height is so much larger than our base. So as it gets closer to being isosceles, if it's not an isosceles triangle, it's getting closer now to being isosceles, which means our area is going to be decreasing. The greatest area we can have for a right triangle is when it's isosceles. So that's the end of this, and I hope this all made sense for you. Just 3 problems involving a sliding ladder and how we can look at the rate of change in area, of an angle, and of a length using common formulas from geometry. The area of a triangle, trig ratio for tangent of an angle, and Pythagorean theorem. Okay? So we're going to pick up with problems in class when we meet again on Monday. Bye!